Good afternoon, everyone. Many of us wonder at this time of the semester if our students are really ready for the coursework they are beginning to undertake. Today's conversationalist will lead us in a discussion of that question. Our topic is using Prerequisite Diagnostic Assessment and Tutorials. Dr. Bogacki is an associate professor in the Department of Mathematics and Statistics at ODU. His research area of interest include computer-aided geometric design and the numerical solution of initial value problems for ordinary differential equation. So as you can see, it's a long area of specialty. In today's conversation, we will learn how to identify specific areas in which students might be deficient, and then we will discuss ways to provide those students with the opportunities to address those deficiencies while we are still early in the course. We hope that you will join the conversation and share your thoughts. Dr. Bogacki.
Well, since this is a conversation, I'll start with a question. My first question is, to what extent do you feel this statement, this opening statement of my presentation applies to you within your discipline that you're teaching in? In particular, what I would like to see is, perhaps outside the calculus sequence, because that's what I'm going to talk about, pre-calculus versus calculus, anywhere outside of that sequence. Can you think of a specific example of a course where a specific prerequisite is crucial to a student's success in that course? So can I ask someone in the audience to relate to that, please?
I'm teaching a course in mathematical biology, and it requires a background in differential equations.
Mm-hmm.
And without that, they will flounder.
Mm-hmm.
Even with
sense.
it, maybe.
Yep. Right. Anybody outside mathematics can?
Music.
Okay.
I teach some engineering technology courses, basic surveying and statics, which relies on trigonometry a great deal, just vector analysis.
Mm-hmm. Okay. You mentioned music. Can you elaborate?
Yeah, the students that enter our program in music need to have fundamental skills with their instrument
Mm-hmm.
or with their voice.
Mm-hmm.
And so we try to measure that in an audition process.
Mm-hmm. Excellent. Well, thank you so much. There will be another opportunity for exchange of ideas at the end of the talk, but this sounds like we already kind of get a common feel for the importance of this, and I hope we can take it from there. So basically, well, I'm going to talk about mostly how this statement pertains to our sequence, but a lot of what we will talk about here will be more general in the sense of what we just discussed, where these prerequisites are so important. Now, let's first take a quick look at how we at this university are tooled up to handle prerequisites. Now, of course, one vehicle is the catalog descriptions of courses, where, of course, we say things like this course requires a certain other course as a prerequisite. We sometimes go as far as saying C or better is required in a certain course to make it to this subsequent one. We actually did that in our department in math and statistics a couple of years ago, where we have changed a number of descriptions that way, enforcing a C or better requirement, and we seem to be seeing some improvement because of that. So again, that's something that a catalog course description. Of course, there's a placement test. There's an alphabet soup of tests of all kinds that can be counted towards fulfillment of prerequisites. Transfers are another avenue. Of course, that includes military credit. There's an issue of banner enforcement, which, for example, when a course requires a C or better in the previous course, then if a student hasn't met that requirement, banner will actually force them to drop that subsequent course, right? So that's an example of something that really does take place. Of course, overrides by, say, faculty member do become necessary in cases like, say, if a course from that a transfer student claims they have taken does not appear on the transformation system, then it may become necessary for the professor to manually evaluate that course to see whether that's really equivalent or not. So we sometimes do that, or other reasons may come up. Now, the system is in place, but there are many issues. In fact, way too many for me to list them all. I'm just going to mention a few. One is placement is a great idea, of course. Now, in our department, we used to have placements that were actually formal placements based on what was called the COMPASS test. A couple of years ago, it wasn't really our choice much, but that was discontinued. Instead, it was replaced with a vehicle based on a much less accurate scheme based on SAT and ACT scores, which were never quite intended for that purpose. That they are not placement vehicles. So anyway, so that's an example of a possible issue there. Another issue is sometimes what happens is I get a student in my class who has an override of their prerequisite requirements signed off by someone else, not me. And sometimes that's okay, but sometimes it turns out that person shouldn't be in the class. And again, there's a problem there where maybe too many people can actually sign off on these things, where it may not always work. Well, I have to go as far as this, though. I mean, we have to be careful. There are all those issues and many more out there, and we sometimes fix them. Like when I see a transformation system reporting a wrong match for a course, I go ahead and report it to the person in charge, and they fix it. But see, even if we had a perfect system in place, I would claim that the issue will still be there. It wouldn't go away. Even if every one of those were enforced 100% correctly and accurately. Why? Well, for one thing, think about this. You have students coming in from previous courses who earned an A in that course versus students who earned a C in that course. Well, of course, they are expected to perform differently, right? Another thing is sometimes a student waits before they take a subsequent course. Now, that may have an impact on their performance, right? They may have forgotten. Of course, there's a lot of research that has gone on issues like learning, retention, and recall, and why does information from long-term memory disappear? Well, of course, discussing those important issues is not a topic for this talk. I'm not going to talk about that, but of course, that's all relevant, right? Now, what we will be focusing on is how we are going to try to address the situation within our calculus sequence. I've been teaching various calculus courses for over 20 years now at this university, and I've been a coordinator of Calc 1 and 2 for several years now. Calculus 3 is not a coordinated course, so again, we just coordinate the first two. These are the enrollments. It has been said that algebra is a language of mathematics, and there's a lot of truth to that. Trying to succeed in calculus without a good algebra background is similar to a student trying to study the original works in foreign literature without actually having mastered the language itself. Because, pretty much that is equivalent, because again, algebra is the language for what we do, okay? Well, of course, algebra, trigonometry, there are many other important prerequisites. Students without those proper prerequisites often find themselves limping through calculus. They don't quite enjoy it. They just barely make it. Sometimes they don't make it. They fail, okay? So there's all these things. Well, again, it's generally not a good thing to let that happen. So now the question may come up, if I taught this for so long, why didn't I do anything about that sooner, right? I've been here for over 20 years. Well, here's why. I can tell you it was always easy enough for me to devise a way to check for students' deficiencies in those areas. It's easy enough. You just give them a quiz or test or whatever you call it, and it's clear. I mean, it was clear pretty much every course I taught, every section had a lot of students in that category. Well, what was not easy was to actually do something about it, to have an efficient way to address those shortcomings. Now, I would say this, the emergence of the online homework technology, which has its share of problems too, but that seems to be helpful to what we try to do here, and it helped us resolve some of those issues. I'm going to show you how those pieces fit together in my talk. Now, of course, others have the same problem. We are not the only ones having it. There are other universities in this country as well as abroad who face the same issues of students not having correct prerequisites. So it only made sense for me to look elsewhere and see what others have done about that. And well, what I found was interesting, but at the same time disappointing, because I wasn't quite able to find something that would kind of do what I really had in mind. It was more like bits and pieces made sense, but the whole thing didn't quite go as far as I want. Like, for example, this particular project, they do an assessment the first day, and they see how students do on their prerequisites, but then they don't follow up in any way as far as intervention. They just tell the students, okay, you have a good chance of succeeding and you don't, okay? And they tell them, okay, those who don't, they tell them, okay, you need some help, right? But they're not specific as in saying, okay, this is what you need to do specifically, right? Well, okay, that's not quite what I had in mind. Another thing is, see, this is an example of a project where I would say the problem there is with granularity of skills, because they test students on the global pass-fail basis. If a student passes a certain number of problems on the initial assessment, they pass the whole thing, and there's nothing else they need to do. If they fail, they have to go through remediation, which is not specific to topics. It's a global kind of remediation. So again, I would like to do better than that and address specific kinds of shortcomings. So again, basically what I did is I picked up bits and pieces from various places, but I also have added quite a few of my own, and then came up with what's now known as PDAT, or Prerequisite Diagnostic Assessments and Tutorials. Assessment and Tutorials. Used to go under different names. I'll show you how the kind of a brief history of the project. But the main objective, of course, is this. That's one of them. Well, there'll be a few others, but it's very important to actually identify those deficiencies in prerequisites early in the course, so that we can actually have some way to remediate those deficiencies, again, early in the course, before those deficiencies start preventing the student from actually performing well in the course itself, right? I mean, it's pretty obvious that we don't want to wait until the final exam, for example, to have that thing resolved. It should be done much sooner than that, and that'll be one issue. One other thing is I want to avoid a uniform approach where it's not like one size fits all, like I say here, because what we need to do is be specific and essentially just have each student kind of go through the process specific to them and depending on their deficiencies. Remedial assignments must be targeting their individual weaknesses and not just kind of overall types of weaknesses for the group. Well, it's important when you give any kind of pretest, which we are talking about here. Early in the semester, we give them some kind of a vehicle, an assessment of their strengths and weaknesses. Well, that can go very wrong. I've seen some high school pretests where students would draw happy face patterns on bubble sheets. Why? Because these were not graded in any way, in any meaningful way. There's no credit associated with those, right? So of course, now we certainly don't want that kind of thing, right? Because that's not what we have in mind. Now, at the same time, so we need to attach some credit to this thing, but at the same time, you don't want to go overboard, because after all, we're talking prerequisites and not the actual course content. So, you don't want to go too far with that. There's a fine line there. Now, as I try to explain to you, sometimes there are cases, not too many perhaps, but there may even be cases where students' deficiencies, some of them may be due to reasons outside of students' control, like they've been placed in the wrong course by someone else. Maybe our transformation system had a wrong entry there. So there may be, of course, probably most of the time it's because the student himself or herself did something that they shouldn't have done. Maybe they didn't study hard enough or whatever. But anyway, without going into details here, we don't want to punish students for coming with the wrong set of prerequisites at the beginning. What we want to do is offer everybody a chance to actually overcome those problems as much as possible. Of course, what we'll see happen here is those students with more problems will have to put more work and more time into this. But that's fine. At the end, though, we don't want to have a kind of grade associated with that being, punishing the students with lower initial assessment scores, as long as they are willing to put the work necessary to overcome those. And we'll see how that works. Now, here's the pilot description. The pilot I ran in 2005, just in my sections of Calculus 2, in the summer and then in the fall. I started by giving a paper and pencil assessment, and I actually administered that at Gonto, Learning Assessment Lab. So it was outside the class. And, well, what happened there was the students were given a certain number of questions within areas that were deemed critical to their success in a given course. Let me show you first the areas in Calc 1. These are the critical areas that we identified as really important for students to be familiar with to succeed in Calc 1. Now, Calc 2 actually has all of those plus some coming from Calc 1. And when it comes to Calc 3, we have areas that actually we compress some of the algebra areas into fewer areas, so that made room for more of those coming from Calc 1 and 2. I mostly just wanted to show you that there's three problems that populate that specific area. So there are some areas that we ask which actually are made up of 3 questions, and a student answers them, and then the professor grades them by hand. And when they issue a grade of A, that means a perfect answer. The third question would actually not have quite the right answer. There's a slight problem. So we give the student a warning with a grade of B, but it's still a passing grade. And essentially what we do is we say, if all the problems within the area either got A's or B's, we let the student pass that area. And they have no more work to do on that area. We pretty much claim they achieve mastery of that area. Okay? Now, another example, in this one we have just 2 problems in this area. In fact, some areas only have 1 problem. So it goes 1, 2, or 3. And again, a student answers it, and the professor gives a grade. And this time, C means a problem. And what really was supposed to happen is the student didn't completely factor expression. They just did some factoring, but not all of it. And that means they really should do more work in this area. But the bottom line is, C is a failing grade in our grade book for problem by problem. We actually have 3 more failing grades: D, E, and F. F means no answer. Okay. So anyway, so there's a gradual kind of progression from C to F, but of course they all mean failing. And actually the instructor enters those grades in a spreadsheet where each student gets all those grades entered for each problem individually. Okay. And of course that means the area was not passed because there was even 1 problem being deemed as failing means the area needs more work, right? There's no mastery yet. Of course, you have to understand, this may seem very harsh, but you understand 2 things. 1, we want mastery. We don't want just a partial credit type, pat on the back. Also, we give students opportunities to get those points back. So this is not something that we say, well, you fail, go away or something, right? Well, so here's a part of what we do about it. The 3 weeks, at least, again, this goes back to 2005. That's how I used to do it in my pilot. There's 3 weeks worth of online tutorials where a student would be assigned tutorial modules based on the areas they failed. And again, those spreadsheets would automatically generate study plans for each student, and there's an automatic procedure in place. So each student gets a study plan telling them which areas they passed and which they still have to work on. And we actually use the homework software, online homework software associated with the publisher of our current textbook. It used to be, when we were using Stewart's book, we used iLearn or Thompson Now was the other name. Then we switched to another book, and we're now using MyMathLab, which is a different product. But all these products pretty much offer the same major features, which are availability of hints. You can do a problem several times over with different algorithmic values assigned. You can actually enter answers in the proper mathematical form, right? Not something you just saw on the screen here, right? So all these features are nice. There's a lot of guidance, a lot of feedback, and for all these reasons, we expect students to get 100% passing grade on those tutorials. Basically, there's no excuse. As long as they put the work in, they should eventually succeed at all these problems assigned to them, because there's all that guidance there in place. Now, here's what we used to do next. On week 5, same spreadsheet would actually generate a paper and pencil assessment, but it was actually specific to each student. Each student got a different set of questions. It sounds complicated, but it was all easy because I made it into a script from Excel to Tech, and it really worked very well. So that part was taken care of. Those assessments were taken at the Learning Assessment Lab. So some were pretty short, some were pretty long, depending on how many areas a student had to take. And then based on those results, which Professor graded again, we generated a 3rd attempt, which some students didn't have to take anymore, some still did, okay? Well, that was the way we did things. Now, here's how we summed it up. All the points that were lost on the initial assessment could be restored by participation in those subsequent experiences. As long as the student did their work, of course, then they could actually part of them could be gotten by participating in the online tutorials, and the other part came from here. Now, what I found when I studied the results from those is there was a tremendous correlation. Now, there were 2 groups of students. Some students did actually participate in online tutorials and got next to 100% on every one of those assigned, and some didn't. Well, those who did very well on these. Those who didn't did very poorly on these, okay? Again, tremendous correlation there. which kind of made me think about this whole design. I'll tell you what we came up with. But, well, here's some other issues. Well, it took too long. 6 weeks is too long. We ought to give the first major test by the end of the 4th week, maybe 5th, but 6 weeks is too long, okay? Again, we want the students to realize the benefits of this earlier in the course so they start doing better on their tests and elsewhere, right? Another thing is Learning Assessment Lab got more and more difficult to schedule as we actually started, beyond the pilot stage, when we started running more sections this way, there were, we needed more time. And sometimes students would encounter long lines, and there was all kinds of issues. We said, well, okay, let's simplify it. We conducted a major redesign in 2007, which went like this. First of all, the initial attempt is now conducted in the first class. They may say we lose a lecture that way. Well, not quite, because the first day is we give a syllabus, we discuss a bit, so there's not that much. I mean, there's some learning going on, but we don't sacrifice all that much on the first day. And then we compress the online tutorials just to the remaining part of the 2 weeks. So by the beginning of the 3rd week, normally students are done with the whole sequence, okay? We eliminated the 2nd and 3rd attempt altogether. So we give all the credit is now restored just based on the results of the online tutorials, which again, you may say, well, is that legitimate? Well, we found a lot of correlation earlier, so that seems to be legitimate, right? I mean, that's, again, it's worthwhile based on the benefits achieved here, right? That's at least our thought. Now, all sections of Calc 1 and 2 taught in the fall and the spring run PDAT, starting in 2007. Some sections of Calc 3 are included. Some sections of the summer school are also running it, but summer has special challenges based on time, so we don't do it in every section in the summer. It's up to the professor. Now, as far as grading, now, of course, the points lost on the first assessment are now restored based on the online tutorials, because there's no subsequent attempts. PDAT overall counts as less than 2% of the course grade. Okay, now, you can hardly say that's excessive, right? Now, it seems to be enough to at least get students to do it, because most of them do everything we ask them to do. But I have a sense, and I actually heard that from some students, that quite a few students do it, not because of the grade, but because of the benefit they realize that this whole thing offers them, okay? So, well, which is a good thing. And speaking of the benefits, who actually benefits from the whole thing? There's 3 groups of stakeholders, of which students certainly are most important. So let's kind of take a quick look at those. How do students benefit from this? Of course, if you think about it, even before we actually grade their initial assessment, even having explicitly identified those skills that we seem to think are important to them, on that, even when they take the assessment, that already accomplishes something, right? So that's number 1. Number 2, of course, we do grade it and give it back to them so they know how they did. And that usually happens by midweek of the 1st week. So it's very early. They get this kind of feedback. That's beneficial. Now, it's beneficial actually to have the online tutorials now in the first 2 weeks. Because think about it, the first 2 weeks are not nearly as busy as, say, midterm or something, right? Students don't have that many things to do, so they don't object too much. If you make them wait longer, it's not going to be quite the same. Plus, we actually keep the tutorials available for everybody. Even students who passed the initial assessment in the area can still do the tutorial. Sometimes they do, because they feel they still need to brush up on a certain area. Or after a deadline, say by the end of the 2nd week, they still want to come back and brush up on that some more, which they can. Not for a grade anymore, but just because they want to. Now, this may be a bit disappointing, and I want to caution against reading too much into this, especially the negative parts. Well, what I mean is this. For example, if you read this carefully, 40% of the Calc 1 students pass 3 or more areas, which is out of 9, okay, on the first attempt. Now you may say, wow, that's really low. Okay, well it is, but then realize this. To fail an area, all it takes is 1 failed problem in the area. Plus, failing a problem in the area sometimes means a fairly minor mistake, which normally would give them partial credit and let them pass. So this is really about mastery. This is really intentionally harsh on the first attempt. And by the way, even with this harsh way of grading it, look at the Calc 2, for example. Half of the students in Calc 2 got half of the areas right. So it's not true that it's impossible to do, okay? And look at it this way too. 75% of Calc 1 students got at least 1 area right, okay? In fact, the number for Calc 2 is 95 or 96, and for Calc 3 is 90. So many of them, the vast majority gets at least something right. Now, almost nobody gets everything right. Look at that too. These are the numbers of, you can see that there's pretty much nothing there. There may be just 1 student or a couple of students, but no more than that. which means that it makes sense. It legitimizes our approach to be selective about the areas, because not everybody loses everything, and hardly anybody gets everything, which means most of them are in between. And we want to know which areas they know and which areas they don't know, so we can target those in the remediation, not just everything. Okay. Now, there's also variation with respect to which areas they know, which they don't know. So you can see like the breakdown of Calc 1, percentages of which areas are actually passed. It varies from student to student to student. Some students like trigonometry, and they forgot all about factoring, and some are the other way around. So it will be difficult to say up front, well, you just review this, all of you, because, again, people differ in their skills. Now, sometimes you get something like this. Look at this. You may say, wow, that's a real low performance in the Calc 3 area called lines and planes. Well, that's something that actually can be very easily explained. We only take, there's one section in Calc 2 devoted to that topic, and that's why, something that's just one section, students don't really retain that well, okay? And yet Calc 3 is mostly devoted to a study of curves and surfaces, which without a good understanding of lines and planes is basically impossible, okay? So we want, knowing that they are so weak on this, that's like a good reason why we want to ask this question, so we get this message across as early as we can. The first day is about as early as we can do it, right? So we do it, and we ask them to brush up on this, so they are ready for those more sophisticated topics coming up in Calc 3. Now, we talked about how students benefit. How about the instructor? Well, the instructor gets to grade these things, so they waste some time, you may say. Well, that's true, but I say there's a benefit associated with actually grading this. They get a first-hand knowledge about what their students know or don't know on day one. So that when they start lecturing on the subsequent days, they actually can adjust the way, like I for example, when I go over detailed steps, I pay attention to this, and I say, I know my class tends to do very poorly with, say, certain types of algebra steps, so I highlight them more than I normally would, right? And let me show you, by the way, again, there's no commonality to that. There's a lot of variation. What I showed here is, see, those green and yellow bars are percentage of students who got most of the questions right within the first assessment on Calc 1. The reds are the ones who got less than half right, pretty much. You can look at it that way. So you can see now each bar represents a different section of Calculus 1 that we offered over 3 semesters. So you can see how much variation or fluctuation there is from one section to the next. So you really can't predict that. These are self-selected samples. I mean, we have some statisticians here in the audience, so maybe they can correct me. But basically, you can't really say up front that we have a solid expectation of those, because they vary so much, right? So it's important to actually ask them those questions and see what they actually know or don't know, which areas. All right. Now, in some real severe cases where a student does hardly anything right, and I get this assessment, I grade all the scores are D's or E's or F's, right? Empty or nonsense or something. Well, I sometimes will contact the student right away, and I'll have a talk with them, and I'll ask, okay, what's wrong? But I'll maybe at least get across the kind of severity of the situation here to make sure that they appreciate how challenging this is going to be for them to stay in the course. And sometimes they need extra help. Sometimes, whatever they can do, we need to figure it out, right? But it's important to get started right away. And actually, I had a couple of students who, following that conversation, ended up dropping the course and enrolling in a lower course, which obviously they missed because they had it transferred, but it wasn't quite equivalent or something. And they figured it would be for the best if they actually enroll. And think about this. We're talking first week. It's before the drop-add period. You can get the tuition back. Everything, all the options are open. We're not talking about failing the first test on the 4th or 5th week, okay? So it's very different here. I think that's another value. So this is good for the instructor, but it's also good for a student. Now, what about the department? The department can benefit from the data generated by the PDAT in a couple of different ways. Like, for example, we had a committee a couple of years ago that looked into the alignment of pre-calculus topics versus calculus, and some of the information that was used in there was actually coming from the PDAT. So that's one way to do it. We can also look at the alignment within the calculus sequence. What I'm going to show you right now is the limited study I conducted within my own 2 sections of Calculus 2 over the spring and fall. It was just 2 semesters, but basically a couple of questions I wanted to know. First of all, do the grades from Calc 1 correlate with the results on the Calc 1 questions in Calc 2? Remember, Calc 2 has some of the questions that are actually based on the previous course, Calc 1. So we would expect some correlation, right? If things are going okay, then an A student would know more than a C student, right? Well, let's see what happens. How about students who waited before taking the subsequent course? Does that affect them? And if so, to what extent? Also interesting, how does it affect them if they are transfer students or if they are retaking Calc 2 because they failed it before, or maybe they got a D, which doesn't allow them to go on, right? Well, again, unfortunately, it was easy enough for me to grab the data from Leo Online for my own sections, but that means there's only 75 students in the sample. These numbers are much lower than all the other data I'm showing you here today. But that's because it took much longer for me to get it and assemble it manually. Well, to answer these questions, I grouped the students into 6 categories. And I defined the recent Calc 1 by saying for the fall, that meant they took their Calc 1 in the preceding summer or spring. And if we're talking spring here, then the recent Calc 1 meant the previous fall, right? If they took their Calc 1 anywhere before that's already a past Calc 1, right? Retake means they failed Calc 2. Transfer, of course, means transfer. So let's see. With all these 6 groups, now I have grouped their performance. Now here's what I did. Again, greens means good, right? Greens means they passed most of the questions, calculus questions. There are 6 questions. They got 6 or 5 right on the first attempt. Black or red means not that good, right? Well, can you identify which bar goes with which group? Well, it's pretty clear. I guess some of it is pretty obvious. So yeah, no surprise here. These are the A's and these are the B's, which is good because that means our grading is where it should be pretty much, right? It means something. Now, what's interesting is a high polarization of the retakes. Some of the students who retake the course got the message that they should study harder, and they do that. They end up here, right? And some of them become those experts because they've seen it all before and they don't do anything. They actually do even less than they did in the first attempt. So they end up here, of course, right? So yeah, we see all that. Transfers, I mean, that's pretty bad actually because that means those students are at a definite disadvantage coming in from elsewhere compared to, say, our own A and B students, definitely. Maybe they compare somehow to the C students, but that's about it, right? So, and I'll tell you, some of those come from good colleges. I know who comes from where, but I'm not going to reveal it. So anyway, there are certain kinds of colleges that really tend to be right there. And maybe some larger study needs to be conducted about this. Now, you may say, wow, all of the students who waited at least one semester got nothing right. Well, okay, think about this. When I say all, I actually mean both, right? Because the study was so small, remember this, right? So when I say, saying that this has to be taken with a grain of salt is an understatement. Perhaps I should replace it with a pound or a ton of salt, right, to make it closer to reality. Because that's, again, for this kind of study to mean anything, your numbers will have to be much bigger than they are. So don't read too much into it, please. But there's something interesting there, of course. So anyway, there's these certain correlations. Now, some of those benefits may or may not convince you, but some questions still may remain. Like, for example, why do we need all this technology? Can't we just throw a lot of homework on day 1 upon everybody and tell them, okay, go do it, say 100 or 200 problems, do it at home. These are prerequisite problems, they're important, do them, and you'll be fine. Well, my take on this is not going to work. A couple of reasons. Here's one. The students who are better, the ones who already know a lot of this stuff, they all have every right to be bitter about that kind of arrangement because they'll be made to do a lot of busy work, which they already know. So why? Just because we are lazy, they should be doing this? That doesn't make any sense. Well, another thing is students who actually are the ones who need it the most, that kind of intervention, will be the least likely ones to succeed because they'll be frustrated by all this massive homework with very little help. Now, of course, you could say this. How about if we replaced it with an online homework type exercise? Well, that will address the second concern, but not the first one. Okay? If we made it just a uniform assessment uniform tutorial for everybody, then it will help the weak ones, but the good ones will still be made to do something they really shouldn't be doing. Okay? Well, another question. And actually, this is what I used to be doing before PDAT. Before 2005, the first day after syllabus, I would start reviewing. I would say, okay, well, here's some algebra that we need to know and all that. And now I come to think about it, that could be counterproductive because the kind of message it sends is kind of like, it goes along these lines. A student says, gee, okay, so I don't know my algebra here, but apparently the expectation is that pretty much nobody else does, because otherwise the professor wouldn't be doing this review they're doing right now, right? See, that's the wrong kind of message to be sending. The message we should be sending is something like this, okay, where it is the student's responsibility for their own readiness for the course. In other words, I really want students to be actively engaged in working on their prerequisites, because these are their own tools that they need. It's not something that we show them on the board and it's kind of like magically transferred to them. They need those tools to succeed in the course that we're about to start teaching on the following day. Right, so again, it's a matter of different philosophy. I've shown you some data here, and of course this data is quite useful when we evaluate the project on an ongoing basis, which we do. Like for example, we calibrate the areas or the specific questions or the point values and such. We keep using those kind of numbers. Also, what's very useful is for me to get feedback from instructors. A lot of the changes I presented here were directly resulting from feedback from instructors teaching individual sections. So again, even though I originated the project, it's critical for me to continue getting that type of information. Of course, feedback also comes from students, and especially when I was running the pilot early on in 2005, I actually solicited a lot of feedback actively. We also did some of that later on. So what I'm going to show you here is a couple of screens of mixed feedback coming from those categories, early and late. And those screens, I'll tell you, I'm not going to keep it up there too long, but it's pretty positive. Here's another screen. The students, generally speaking, they seem, at least many of them, seem to appreciate what we're doing here, and it's great. I mean, that's the kind of thing that when I read this, I say, well, that's probably worth keeping as a feature, because now, is everybody a fan? Wouldn't go as far as that, okay? There's some occasional criticism, and I would say this. Some criticism goes along these lines. Well, these tutorials are too long. Well, I'll tell you this. By design, we want the tutorials per area to contain about 10 to 15 questions each, whereas the original assessment only has 1 to 3. So the assessment is much shorter, naturally. Tutorials are much longer. Well, so using a software jargon, I would say that's a feature, not a bug. Okay, sorry, right? Okay, I mean, that's what, well, anyway. But some of the criticism is not something we can or we should dismiss quite as much. For example, not being ready for that assessment the first day, or expecting some kind of warning, that's a good idea, actually. And in fact, to tell you the truth, I tried that as a pilot this semester. Just a couple of weeks ago, before my Calc 1 section, I contacted my students. I sent them pretty much 72-hour early notice of a PDAT coming up on Monday. I sent them a practice set of questions for, I sent it in both PDF form and online, so they could choose which one they want. Now, I'll tell you, the participation wasn't overwhelming, far from it. There was only a few students participate, but I would say the results were encouraging enough, especially when I looked at who participated and how they did. So I wanted to continue this. Perhaps I'm going to give them more time, or maybe I'll try to send a reminder, send them an early one and then another one, or somehow try to beef up the participation in this kind of early experiment. But it seems to be, if you think about it, it's especially true for Calc 1 students, because they are new to this, right? Calc 2 and 3, mostly they come from our own Calc 1, so they really know what to expect, most of them, right? But we probably could try something like that there as well. So again, this is just an example of the kind of thing that we do on an ongoing basis. We continue modifying and adjusting the parameters of the project to make it work even better, right? That's the idea. I guess it's time for me to ask you some questions. And the first one was largely something we talked about already, so let's try to focus on these other two. How likely are your students to exhibit prerequisite deficiencies? I mean, we talked about the importance of some of those in different areas, engineering or music or in mathematics. And then if you detect them, do you have how do you deal with those? Or do you? Or I mean, any thoughts on that, please? Because I would like to see if there's something we can arrive at as maybe not a consensus, but at least some type of understanding. There are certain commonalities to this topic of having prerequisites not completely mastered, and then how does that prevent the student from fully realizing the benefit of the course they are currently enrolled in, right? So again, anybody would like to please address any of that? Just raise your hand and get the mic, yes.
I can address that a little bit. I teach an English grammar course, and the Virginia schools don't offer grammar. So I get mostly recent transfers, juniors, who haven't really a sense of even what an adjective is. So they're coming into my course to take this higher level class that they're going to have to then teach their students, and they're terrified. So I go back to square one, old-fashioned pedagogy, and they make flashcards.
Now let me ask you this, do they tend to have the same deficiencies, all of them, or are they diverse as far as the types of deficiencies?
Mostly the same, with the possible exception, and this is quite interesting, when I get English as a second language speakers, they're light years ahead of the Americans.
Yeah, well, yeah. Well, because the grammar is probably the first thing they
That's what they
learn,
learn,
but
yeah.
that's how I learned it initially. Yes, for better or worse. I mean, that's not always good, but yeah. Anybody else, please?
In music, this is a huge problem because the programs in our region, the high school programs, are pretty weak. So we get students who are not prepared to play their instruments well, and their understanding of music theory is really at a low level. So we offer remedial courses, a theory course that they can take prior to the one that actually counts towards graduation. And we have something just under 50% of our students taking that course. In applied music, we have a remedial number, and that they can register in, and then they have 1 semester to get their skills up to the prerequisite level to begin study for credit. And we're finding that's why I'm here today, is because I'm looking for new ways to handle this problem, because it's not getting better, it's kind of getting worse.
When you say they can take those remedial courses, do they choose those courses themselves, or is there any mechanism in place to somehow assess them first?
Everyone who comes into our program, whether they're a transfer student or a new student, takes a theory placement exam, regardless of their background, where they've gone to school, or what, even if they have a degree. We place them according to the results of that test, that pre-test.
Again, my other question would be, do you see a diversity in those shortcomings, or are they pretty much universal? You mentioned 2 areas, the ability to play an instrument and the theory of music. Are there different categories of individuals exhibiting some, but not one, not the other, or is it usually the same student who has both problems?
That's a good question, but I think I'm not sure that I have the answer to that question, and I think it's divided by area, which may not be of any interest to you. Vocal students tend to come with weak theory skills, but they tend to come with strong applied skills. The instrumental students, it's a mishmash, but typically weak applied skills in the instrumental students. So,
Great. Yep.
yeah.
Thank you. Anybody else, please?
I'm teaching intermediate accounting. Actually, we have exactly the same problem, because I mean, prerequisite is principles accounting, and we do give an assessment test on the very first day, and normally less than 50 students pass. So that means I mean, a lot of students fail, and those those students are required to go over a certain area in the principles of accounting, and then has to take additional test. Because if they fail, they're going to lose like 1 or 2% of the grade immediately, and then once they go over the tutorials, and then if they pass the subsequent exam, then they will recover those points. Yeah.
Okay. And once again, the question is, do you see certain different kinds of skills that are missing for different kinds of students, or do you see pretty much all the students exhibiting the same deficiencies, or is it diverse?
In our assessment test, I mean, we just ask one part of one topic of the principles of accounting, which is about accounting cycles, because I mean, this is about like in mathematics, right? If we do not understand addition or subtraction, we cannot go advance. I mean, move over. So if students cannot understand, basic things about accounting cycles, they cannot, understand everything, basically everything about intermediate accounting. So we just give questions on that specific topic only, and then assess their, ability. Yeah.
Okay. Well, thank you very much. Anybody else has any comments, please?
I don't teach a class. I'm an academic advisor, and I see students at orientation. And you had mentioned earlier about the SATs and ACTs always not being a good predictor of success. Also, students come in with AP credit sometimes for calculus, and one of the things we typically try to do is suggest to those students that they go back and talk to the professor to see whether or not their math skills are at the level that they should be. But I've found over the years that a lot of students have unrealistic perceptions of what they can do. And so it's real difficult since we use the SATs and ACTs. I know you mentioned we used to use a compass, and we recommend that for students, but again, students say, well, I really don't need that. So, one of the things I guess your PDAT program, it seems like it needs to be something that they should use in the lower level courses too. I don't know if they do the 102,
They do
162.
some of that. 162, 163 does some variation of this approach, yes.
Right, because I had a young man I saw the other week. He placed into 162. He withdrew from that class, and I talked to him and I said, well, maybe you need to go back and take 102 to get a better foundation. He went back and took 102 and got a D+ in 102. And then he came back to see me and told me he wanted to be an engineer. And I said, well, seems like you're gonna run into some obstacles with that. But he was focused, his parents wanted him to do it. And I have referred him over there with a lot of trepidation. But I say all that to say that, what can be done since we use the SATs and ACTs, and it's always not a good predictor. And students follow those things, and transfer students come in, and it needs to be something that can give students a better view, a realistic view of what they can expect in those classes.
Well, it definitely sounds like we're on the same page here, so I want to applaud you for doing what you're doing, and please keep up the good work, because we struggle on our end, and it seems like you can just do, help us do our job better, but we need to keep doing it to hopefully see some good results. Thank you.
But you said it is used in the 102 and the 162?
Well, 162, 163 does have some version of it. It's different parameters, but based on the same idea. 102, I'm not sure about. I don't think, I'm not sure about that. Well, thank you very much. Now, what I would like to do now is just ask you if you have any questions, because these are all the questions I had for today. Yes.
Thank you. I just have a comment, and I'm sorry it's a little flippant, but I did read an article. I read the title of an article which said, if mathematics is a language, how do we swear in it? And I think your early slides actually answered that question.
Thank you. By the way, Professor Adam will conduct his own conversation on using humor in the classroom, so not just there, but using conversation as well. Thank you very much, John. Anybody else?
Yes. A quick question in terms whether your program actually had any impact on the final student learning outcomes, for example, as measured by final grades, or did you see any difference, for example?
Well, again, some of the studies here where some things are easy to measure, some are not so easy, and I really, you have to understand, some of this I did in my own spare time, and some things were just easy to tabulate in Excel. So I'm afraid I don't have a ready answer for your question right now, because I fully realize that to really make valid points about some of these outcomes, we need a more profound study, more, better structured and everything. And I just shown you some partial data that I have.
Then a follow-up question. For example, as they move from calculus 1, 2, and 3, do you see any difference, for example, for the same group of student, or you don't have that kind of data?
No, again, I've done that Calc 1, 2 progression. I haven't done it on a 1, 2, 3 basis. But again, that'll be another thing to do. But my fear would be if I did it based on my own students, the sample would be even smaller. So you would need to really have a better methodology where maybe someone with better access to Banner can actually pull the data out and just do it without having to manually go to Relay Online and write it down, which is what I've been doing. Yep.
Thank you.
Very much.
I remember you mentioned groupings based on the assessment test, and I just want to know how you make a groups. I mean, you mix good students with like the bad students in the same group and encourage discussions among them, or?
Oh, no. Okay, but basically, I referred to that a couple of. I'm not sure which exact occasion you're referring to, but one kind of student I approach in my office is the very weak students, and that's a group that fortunately is not too large. I try to just limit it to maybe 1 or 2 students per semester, where they really merit some, special intervention. Where and we do that, but that's a small group, and most everybody else is really. The key idea about all this is I'm trying to get the students classified based on their individual deficiencies. And let them, first of all, make them aware of those. And sometimes, you see those comments by students where they say on the assessment, when they return it to you, they say, oh, I'm very sorry, but I now realize I should brush up on these topics, and I will do that, I promise, or something like that, which whether they do or not, I don't know. But there's at least some realization, so they kind of, they work on those. And of course, based on those deficiencies, they are grouped based on who needs what intervention. So that's the major way in which we group students, but these groups overlap. There's no like 3 or 7 groups or something. It's overlapping groups depending on who needs what. Some students end up doing a lot of remedial work. Some may end up doing 1 or 2 areas only, right? So for some it's an easy A, right? But for some it's a lot of work, but it generally pays off. Right? I don't know if it answered your question, but there's a couple of different ways you can approach the topic of grouping. I did it for statistical purposes. We can talk about after the conversation as well. Right? Anybody else, please? Thank you for your attention. Thank you very much. If you'd like to contact me about any of the things covered today, please email me. Right? I'll be happy to get in touch with you, especially if you want to use some of that, follow up on some of these things in your own discipline. I'll be excited to hear about that. Thank you.